Are you speaking?
Hello, sir. Hello.
Am I audible now?
Hello. I have a doubt. Hello.
Uh,
Hello. Can I ask?
Hello. Am I audible now?
Yes, ma'am.
Yes, ma'am.
Yes. It's a doubt session for week 6, and let just let me just share my screen first, and you can just we'll start with the activity one first, or
Hello, ma'am.
hello.
Ma'am, before you start, ma'am, I have a request, ma'am.
Yes.
Ma'am, can you just post this recorded session link in calendar, ma'am?
Sorry.
Ma'am, can you post the link of recorded session in calendar, ma'am? Because it is easy to find from calendar. Because, ma'am, in every subject, for example, CT or stats, the link has been posted in calendar, ma'am.
Yeah, but now you've already joined in, right? So you
Because,
don't
ma'am,
need it right now.
we have to go to the YouTube link of IIT Madras, and then we have to find the maths, and then we have to search the live lesson recorded session, ma'am. So instead of that, ma'am, please post the recorded session link in calendar, ma'am. Like other subject,
Okay.
like CT and stats and English.
Okay, I'll ask the team and see what can be done about it.
Ma'am, I have a request too. Actually, while uploading the videos, could the caption give the summary of what the video is about? Because it's very difficult to figure out what is happening.
Sorry, what? Come
While
again.
up, while uploading the videos, could you please put the summary in the caption? It just says Maths 1, that's it. So it's very difficult to know what is going on in the video. Well,
Yeah.
Hello, ma'am. I have a question according to about qualifiers. So can I ask?
Can we just wait for a minute, please? And then we'll start.
Excuse me, ma'am.
Excuse me, ma'am.
Ma'am, I have sent a doubt in the chat. Means I don't want the answer or the method to that, but I am having a problem. So could you please check that I have sent in the chat?
Hello. Yes. What is it?
Ma'am, I have just sent a doubt in the chat. I don't want the answer. I don't also want the method, but I am having a specific
We
problem.
are taking some time, but we'll be starting in 5 minutes. Can you wait for 5 minutes?
Yes, ma'am. Ma'am, excuse me.
Yes.
Ma'am, I have a doubt, but it's not from week 6.
Okay, then we can take your doubt maybe at the end of the session, if that's okay.
So, ma'am, I have to come in end of the class.
It's up to you.
Excuse me, ma'am.
Yes.
Ma'am, I have a doubt on week 6, ma'am.
Okay, we'll be starting with the doubts of week 6 in maybe a minute or two.
Oh, okay, ma'am.
Ma'am, I have sent a doubt of week 6 in the chat. I don't not want the answer. I am not asking the method also, but a specific type of problem is occurring. I want to clarify that.
We'll start in some time. We'll start in 5 minutes.
Okay. You just confirm, are you able to view or not in the chat? Otherwise, I will be sent.
Ma'am, is there any qualifier doubt session?
It's for now. It's just this one is just for the week 6. So
So, in a calendar, there is some, or it's not.
Ma'am, I have sent you one question in the chat. Are you able to view that?
Okay, yes. Can you just tell me the question number and which? Can we start with the first the basics and everything? Are there any doubts from the basics of week 6?
And I have sent from week 6 only.
Okay, we'll go step by step. We'll first go with the basics. If there are doubts in the basics of week 6, you can ask it.
So,
Anyone
ma'am,
else?
No,
ma'am,
ma'am.
other doubts is after this session.
We are going to take the doubts of week 6 now. We're going step by step. First, we'll just do the doubts from the theory part of week 6, if there are any, and if there are not any doubts, then we'll move to activity 1, then activity 2, and then we'll just continue the doubts in this manner.
Ma'am, from week 6, I have sent you a question.
Which activity or practice is it from?
Ma'am, means it is from graded assignment. I don't want the answer. I don't want the method also, but I just want to ask a specific thing. If you could view the question, then I could ask. Means not the answer, not the method, but another type of problem.
Okay, so just tell me the question number in the graded assignment.
Yes, ma'am. It is graded assignment week 6, question number 3.
Okay.
Are you able to view, ma'am?
Yes.
And the question is that when I'm putting the values as per giving the question, there is one step where we have to take log on both sides and then finally compute. But the problem is happening is that depending upon the base of the log we take, the answer is differing. Means when we are taking base 10, the answer is coming different, and when we are taking base e, that is ln in the calculator, the answer is coming different.
Hold on. Just tell me the question number first.
Yes, ma'am. Graded assignment week 6, question number 3.
Okay. What's your doubt?
Ma'am, are we allowed to discuss the graded assignment before deadline?
Not allowed to. We are not
I am
allowed
not
to.
asking the answer. I am not asking the method also.
Can you just hold on for a second, please? I've understood what you're trying to say.
Okay.
We're not discussing the questions there. He has some doubt in the question itself. We're not discussing the answers. Yes. What is it? What was your doubt?
Ma'am, my doubt was while putting the values as given in the question, there will come one step where we have to take log on both sides to solve the problem. So the problem is occurring that when we are taking the base 10, the answer is coming different, the final answer. And when we are taking ln, that is base e, the answer is coming different. Since in the question nothing is mentioned, so could you please
It doesn't matter what, if you're taking log on both sides, it doesn't matter which base you take.
but in case of base 10, the answer is coming different. In case of base e, the answer is coming different.
Then you must have made a mistake.
Okay. Means in general, if nothing is mentioned, then which base should we take so that the answer in the exam will be correct? It means which is considered. If
If you're
nothing is
taking
mentioned.
log on both sides, you can take the log with any base. It doesn't matter. As long as you're doing it on both sides.
Okay.
Okay. So there's no, I'm assuming that there is no doubt in the theory part of week 6. So we'll start with the activity 1 questions. You can ask the questions from activity 1 if there are any.
Ma'am, excuse me, ma'am.
Yes.
Ma'am, this is regarding to this doubt is regarding statistics, ma'am. Statistics weeks is there's two parts of graded assignment, ma'am. Graded assignment 1 and graded assignment 2, in which the graded assignment 2 is a bit
This is
kind of like
regarding the math 1. This is a math 1 session. This is not a stat session.
okay, ma'am. But I don't know what to do in that graded assignment second one, ma'am. Statistics. Like
You'll have to ask
should
the
we
one that
upload the
handles
file?
stats. You'll have to ask the one that handles stats.
Okay.
Okay. So any
Ma'am,
doubts from?
Ma'am, in 6.1, may I ask question number 5?
Yes, that's what we are discussing. Which question? Which question is it from 6.1?
Ma'am, question number 5.
Okay. So do you have something particular to ask on question number 5, or is it just do you want me to do the whole question? What is it?
Ma'am, I just could not proceed.
Okay, till what part have you done?
Ma'am, I'm just trying to open my window.
This is the question. You have to find the domain of this thing. So we'll start with this, the domain thing. I'm assuming that you don't have any specific part that you have a doubt in this question. So you have to find the domain of this thing, right? This is your function.
Yeah.
And we know that the domain for the logarithmic function, you need your argument to be greater than
zero.
this to be greater than 0, right? So you want this thing to be greater than 0. This is x this is this, right? So you want this thing to be greater than 0. And this is, so either you want both of them to be greater than 0, this and this factor, or you want both of them to be less than 0. There are like two cases. The first case is when you want x to be greater than 0 and minus e to the power 3x plus 27 to be greater than 0. For that, you want e to the power 3x to be greater than minus 27. And if you just change the signs on both sides, you get this. You want this thing, right? So this will.
Yes, ma'am, I got stuck here.
Okay, just take natural log on both sides. You'll get natural log of e dx less than natural log of 27. This is because it's a natural log of x is an increasing function, right? This doesn't change. Just take this, you'll have 3x.
Ma'am, can you repeat your last? Ma'am, last, what did you mention about ln x increasing?
You were able to do this till this point, right?
Yes,
so
ma'am.
When you have, you must be familiar with this, which is when you have log, natural log is log base e, right? So when you have your base, we denote it by a, right? So when you have your base greater than 1, then your logarithmic function log base a x is an increasing function. In fact, it's a strictly increasing function.
Yes, ma'am.
When your a is less than 1, can't be less than 0. So it's, when this happens, your log of ax is a decreasing function, strictly decreasing, right? We'll just use that here. Okay.
Actually, ma'am, she's asking for the equality sign. You said the function ln x is increasing, then this equality sign won't be changed. So I thought she was asking that part.
No, sir, no, ma'am. Equality, I'm okay. But what do we do after this? I mean, how did we reach the ln e to the power 3x to 3x?
27 you can write as 3 power 3. So 3 will come in front and 3 will cancel. So x less than ln 3.
Guys, I'd appreciate if no one talks in between unless you're asked to speak. It's just getting a little messy if everyone keeps talking in between.
No, I was just helping her to get the answer. I was just saying 27 can be written as 3 power 3. So 3x less than ln 3 power 3. Then by power rule, you can bring that 3 to the front. So 3x less than 3 ln 3. 3 and 3 can cancel, and then you'll get x less than ln 3.
Okay, thank you for your help. Can we proceed now? So I hope this part is clear. Why do you not change the sign there?
Yes, ma'am. Yes, ma'am. That's
we don't
clear.
change the sign here. And then you can just, as the person who was talking said, this you can take as this thing. Hope we have not made a mistake so far. And then you can just take this thing here, natural log of 3 and 3x, and get a natural log of 3 thing. Right? So your x, and from here you get your x is greater than 0. So now you have two conditions on x, which needs to be satisfied simultaneously. Your x is greater than 0, strictly greater than 0, and strictly less than natural log of 3, which gives us x belonging to 0 to natural log of 3. But we're not done yet. You get the other case. We're done with this case. The other case is x less than 0. Minus e to the power 3x plus 27 less than 0. So we'll do this. You'll get the same thing, but in this manner. So you'll get this here. This sign just gets changed. I mean, earlier we took less than, now we're taking, earlier we took greater than here, right? That's when we got this. And now we're taking less than, so at the end we'll get this. So it's in the similar manner like this one. We'll get
Okay,
this.
ma'am.
So you have this, and these two conditions cannot be met simultaneously. So this has no solution. So this leads to no solution. I hope that's clear.
So, ma'am, so you're saying that because x cannot be less than 0 and also at the same time x cannot be greater than a natural log 3, so we will take it as invalid option.
Yes, this is an invalid case.
Okay, ma'am.
Can you scroll up? I didn't understand the why did we reach invalid state?
Where?
Why was minus e power 3x greater than minus 27? Also in the accepted answer, I'm able to see 0, ln 3. That's the accepted answer. It doesn't say no solution.
I never said there was no solution. I just said that this case leads to no solution. We have two cases, and
okay. You're saying the
this
case
is the
leads to,
solution
okay.
here.
Okay, got it.
Okay. So, is this fine with everyone? Can we move on to any other question? If we have.
Can you help me with the fourth one?
Fourth one from activity 6.1?
Yeah, 6.1, fourth one.
Okay. So here. We have this as the base, and then this thing here. We need to find the set of all x for which there are no functions of the form this. So you must be familiar with this thing. When you define a log function, this is how you define it. And you want your a to be strictly greater than 0, right? And your x to be strictly greater than 0. These are the conditions on a and x. A here is x plus 1 by x minus 1. So you want this thing to be strictly greater than 0. And you want this thing, x square plus 1, x square minus 1, to be greater than 0. So if you want this thing to be, that means you want this to be positive. Let's just deal with this one first. So x plus 1 okay, so if you want this to be greater than 0, you would either want x plus 1 to be greater than 0 and x minus 1 to be greater than 0 both. These have to be, these two conditions have to be met simultaneously, right? This will lead to x greater than minus 1 and x greater than 1 simultaneously. So we can just simply say x greater than 1, because when x is greater than 1, it's obviously greater than minus 1. So you want your x to be greater than 1. And then you want this to be true as well. This is not optional. These two conditions have to be met. We'll find an x which satisfies this and x which satisfies this as well. So for this one, you need x square plus 1. Okay, let's just get done with the first one. This one. And there are, this was like, you can call it as case 1 in this one. Then you can just do other thing where you take x plus 1 less than 0 and x minus 1 less than 0. So either you take both of these to be greater than 0, then is when this thing is greater than 0. Or you take both of them to be less than 0, then also this whole thing is greater than 0. So we're considering this case now. This will lead to x less than minus 1 and x less than 1. This will just give you x less than minus 1. Okay, and one is the case when you take your x to be less than 1, here, greater than 1, and one is when you take it to be less than minus 1. And if you look at this one, you'll get x square plus 1. So this is always greater than 0. You don't have to worry about this fact. Let's just focus on x square minus 1 factor. You want this to be greater than 0, right? That means you want this thing. Or you can just say you want x to be not from minus 1 to 1, right? So you want x to be here. And you don't want x to be 1 or minus 1 either. So let's just do this. Because if your x is 1 and minus 1, this will lead to 0. Not defined thing here. So you don't want this thing to be included. That means your this thing is acceptable, right? And that's what you're getting here. X less than minus 1 and x greater than 1 thing.
Yeah, got it. But so when we are deciding the answer, we should take base also into consideration as well. So base also we should check, is it?
Yes. Yes.
Okay.
Base
Okay,
has
got
to
it.
be greater than 0 as well.
Okay, got it.
Ma'am, sorry to interrupt you. I have a general doubt. Can I ask?
Go ahead.
Yes, ma'am. My CCC is 3. Else, can I choose 4 subject in this term?
I'm not sure of it. Can I just let you know about this in the next class?
Okay. Thank you.
Excuse me, ma'am.
Wait, hold on a second.
Okay.
So your x has to belong here, and the question asks what values of x should not be considered.
Yeah, I got that. Yeah.
So it's this one,
Yeah,
right?
-1, 1. Yeah, that's correct.
Okay. Okay. That's just, I hope there are no other doubts from 6.1.
Question 1.
Question 1. Okay.
Yes, ma'am. Question 1.
We have, for which points on the Cartesian plane will the equation x equals to log base to y equals log 0.2 y. Okay. You have an x here, that means you have 2 to the power x equals to y, right? And 0.2 to the power x equals 1. Power x equals 0.2 to the power x. X equals 0. Then you can just put it there. 0 equals log, let's just set the equation. Yeah. The power 0 equals y, where y is 1. Is this okay? Is this okay with whoever asked the question? Okay, any other doubts from 6.1? Are there any other doubts from 6.1?
Yes, ma'am.
Yes.
Ma'am,
is
I
it?
have a doubt in the previous question. Just
Which
previous one.
one?
Please.
This one?
No, ma'am. Previous one. Yes, ma'am. This one. Ma'am, here, can you elaborate this x square greater than 1? How you get this x values should not be equal to -1 to 1 closed interval. How you get these values from x square greater than 1?
First thing here is we don't want x to be plus minus 1 because it's clearly visible from here. If you put a 1 here, you'll get 0 in the denominator, which is not defined, right? And same is the case with minus 1. So plus 1 and minus 1 can't be, x can't be plus 1 and minus 1. Okay. And about the values between these. Okay. Have your x square greater than 1. That means it's x greater than plus minus root 1. Okay. It's x square greater than 1. Of x and x. Let's just write it this. Or you can just write it as x square minus 1. Just looking for an easier way to. Yep. This is perfect. Either you want both of them to be greater than 0, both of them to be less than 0. This will lead to x greater than 1 and x greater than minus 1. And the other case is going to lead to x less than 1 and x less than minus 1. This leads to x less than minus 1 and this leads to x greater. Is that all right?
Yes, ma'am.
Are there any other doubts from 6.1? Okay, let's just move on to 6.2 then. Any doubts from 6.2?
All three are like little troubling. Can you go through all three?
Yeah.
Yes, ma'am. I have a doubt in 6.2.
We're quickly going through all three, so your doubt will be covered. The first one's the only difference between the graph of log base 2x and log base 2x minus 1. Will be, okay, so ordinate value is the value of x, right? Ordinate value, first option is the ordinate value of gx will be 1 more than the ordinate value of fx. So this is your fx. And so that would mean that you have to add 1. The first option suggests that you should add gx will be 1 more than the ordinate value of fx. This is what it suggests, which is not the case, right? This option can't be correct. This is fx, this is gx. And to be precise, this thing is not the same as this thing. They're not the same, right?
Yeah, I get that. Yeah.
So this option is incorrect.
Okay.
The first one. Moving on to the second one, the abscissa size. No, the abscissa is the value of x actually. Coordinate is the value of y. Wait. The coordinate is your y coordinate. And this, that's what we did, right? Yeah, I think we did the right thing before this. And then the second one is the value of, it's about the value of abscissa. So abscissa value of gx will be 1 more than the abscissa value of fx. So this is fx. If you'll find the abscissa value here, it's basically 2 to the power y. And here you have 2 to the power y plus 1. So it is 1 more than, this is the abscissa value of fx, this is the abscissa value of gx. The option says the abscissa value of gx, this one, it is actually 1 more than the abscissa value. This is the correct option.
Okay, okay. I got confused by abscissa and ordinate. Okay, okay. I get that. So abscissa is the x value, like x-axis value.
Yes.
Ordinate is the y-axis value. Okay, got it.
And then third one is not true, obviously, because first one is not true. The third one's incorrect as well. And fourth one suggests that there will be no difference, but there is difference, so this is incorrect as well. Moving on to the second one. You have been given a function this. This is the given function. So let's just look at the graph of this, right? This is the graph of natural log of x. This point is 1, 0. So if in case you just take the mod here, that means you're only taking, so if you put positive values here, it's the same as natural log of x. But if you put negative values here, you'll get natural log of minus x. Right? And you only put positive values of x in this, right? Domain of natural log of x is 0 to infinity. That's the domain. So we don't put any negative values here. This function doesn't take any negative values, but here you can take negative values, right? So for positive x, it's just the same. And for the negative one, because now this function can take negative values as well. Whereas your natural log of x, this cannot take negative values, right? So if you take negative values here, you'll get the same thing, but on this side. This is what you get. Being the mirror image of this along the y-axis.
Ma'am, so the left hand side graph is the graph of ln mod x, is it?
No, this whole is the graph of ln x, mod x.
Oh, okay.
This is just the graph of natural log of x.
Okay. Positive also, negative also, both combined makes a
yes,
mod x. Okay.
Now coming to the options. First one, this is clearly not an increasing function. First one's incorrect. Second one says the straight line x equals to 0 is an asymptote. So x equals to 0 is this line, right? This is your x equals to 0. And this indeed is an asymptote. Asymptote means when your y tends to infinity or minus infinity. In this case, minus infinity. Your x tends to 0, which it does. So x equals to 0 is an asymptote. This is the correct one. And third one is the inverse of E mod x. Sorry. So if this is an inverse of, that's the question. Are these two inverses of each other? So just to even think of an inverse of a function, you need the function to be 1, 1 first, right? And this function is 1, 1. Is it? It's not 1, 1, right?
No, not one.
It's not 1, 1. So we don't have an inverse for this function. But if we take it from 0 to infinity, if we restrict the domain from 0 to infinity, this will have, then it will become natural log of x only, right? And the inverse of natural log of x is e to the power x. So if you restrict the domain, it will have an inverse. But if this is the domain, that's the domain right now, we don't have an inverse of this. This option is not correct.
Will it have an inverse if the restricted domain is minus infinity to 0? That's also correct, right?
Yes.
Okay. Okay.
It's minus infinity to 0, then also it has an inverse.
Correct. Got it. Thank you.
Okay. The fourth option is the domain of f is. Okay, let's just write what f is. We have to find the domain of this. Domain of this, as we've already written it here. It's r minus 0. So you can just put any value of x because this will eventually be positive. This is the mod function. But you can't put 0 here. That's the only restriction on the domain, and everything else you can put here. So it's basically the same thing as this one. This one's correct. Coming to the third one, where fx is log base 2, then log base 2 again. This is your function, right? Now this works is first you would want x to be greater than 0. From here, you want this to be defined, so you would want x to be greater than 0. This is the first condition. Then you would want log base 2x to be greater than 0, right? For this to be defined, you want this to be greater than 0 for this thing to be defined. If there's anything that someone doesn't understand, you can just ask. Okay. So you want this
No,
thing
ma'am,
to
it's
be greater than
clear.
okay. This thing is now that if you take log with a base, we've already discussed this. So if you take this thing, it's an increasing function if a is greater than 1. So here your a is greater than 1, it's 2. So this is an increasing function, right? Or in fact, your 2 to the, you can just raise both of these to the power 2. So you'll get a 1 here, and you'll get 2 log base 2x. You have to be very careful about this inequality thing. This here it doesn't change because it was an increasing function. Your 2 to the power x is an increasing function. That's why the inequality doesn't change. In case it's a decreasing function, this inequality changes. So this will give you x greater than 1. Okay. And then third condition that you want is you want this whole thing to be greater than 0 again. So you want first thing is you want this greater than 0, then this greater than 0, and then finally this greater than 0. We again do the same thing. We raise this to the power 2. So you get 2 log base 2 and then this thing. So this is it. Log base 2x. This is what you get. And then we'll again raise both of these to the power 2. We're just applying this function here, right? This is the function that we're applying. We consider these to be the arguments of this function. And because it's an increasing function, the inequality doesn't change here. So this will give you this thing. Want to be greater than 2. So from here you get greater than 2, greater than 1, and greater than 0. We can just club them together and have this thing greater than 2. So you want your x to be here. This is one thing about, so the option 2 automatically just becomes incorrect. Option 2 is incorrect. And about the 1 part of this. So if you have a composition of functions, let's just say this, because we have composition of 3 functions here. And if all of them are 1, 1, this is 1, 1, this is 1, 1, and this is 1, 1 as well, this whole thing is 1, 1, right? So you here have log base 2, then again log base 2, and then again log base 2, then something here. So all of these are 1, 1 functions, and this whole is a 1, 1 function as well. The first option should be correct. composition of 1, 1 functions is 1, 1.
Got it.
Moving on to the third option. So
Second one, how is it? Domain.
we just saw the domain of the function, right? What the
Okay,
first one
okay.
says
Two
that
things.
it's
Got it, got it, got it.
okay. Then the third option suggests that f has an inverse. So it's a 1, 1 function, and so if your f is from its domain to its range, that's what you basically consider. There's no codomain given, that when you take range here, right? So if it's a 1, 1 function, then it's an invert. It has an inverse. It's an invertible function. So f has an inverse is true as well. Wait.
Here,
But you've
F
not
we
been given
understood.
the domain.
F we understood that it is 1, 1, but it should also be on to, no, for it to be inverse. How to make sure it is on
But the
to?
codomain, that's what I was saying. The codomain is not given to you. So if in case your codomain is not, which is the case in most of the questions, you are not given codomain. That's when you take the range here. So if any
Oh,
function
okay.
is taken from its domain to its range,
Yeah, then it is 1. Correct, correct.
yeah,
Okay,
provided
okay.
it's a 1, 1 function, it is a bijective function.
Oh, R is okay, range. Okay. I thought R was real. Okay, got it.
Range. No, no. But it depends, since the domain is not mentioned for the function as well. So if you will take the domain to be from 2 to infinity, if you consider the domain to be this, then is when you say your f has an inverse. Otherwise, it doesn't.
Correct, correct. Got it.
But that's where it is defined, so it has an inverse. That's where a function is defined, right? And the last one is the straight line x equals to 8 is an asymptote of f. We drew the graph of this, right? No? Okay. We can just see if we actually, it's not very easy to draw the graph of this one. Let's just, asymptote means if since the y should tend to either infinity or minus, right? So log base 2, if your x tends to 8, because your log is a continuous function here from 0 to infinity. This is a continuous function, right? This log function is a continuous function in this domain. So you can just, you don't have to take the limit, you can just take the limit instead. Limit x tending to 8 can be taken instead. This will give you log base 2, log base 2, log base 2. And you can just put 8 here. It's not the general case when you check the limits of things. But in this case, we can, because it's a continuous function. This will give you 3 here. This will be, this thing will be 3. And then you'll have this thing. This is your limit. And it's not tending to either infinity. It's not tending to infinity. It's not tending to minus infinity. It's not tending to any of them. So this x equals to 8 is not an asymptote. Okay.
How do we conclude? I didn't understand that last part. It's not tending to infinity. So
what's the definition of an asymptote? So when you say that your x equals to 8 is an asymptote, you actually mean for the function fx, let's say. You mean that your function tends to either infinity or minus infinity when x tends to 8.
oh,
That's
okay,
what
okay,
you
okay.
mean.
Got it. Okay, okay.
And graphically, if you look at it, it turns out to be like
Yeah,
this.
yeah, yeah. The previous question, ln of mod x.
Yeah.
X equal to 0. Got it.
We're done with the second activity.
I have an intuitive question here. You can quickly answer this question. Log of 2 of log of 2 of log of 2 of x. Can you go to that question? Go to the question on top. So while I was thinking, I was like thinking in this sense. Just tell me where I'm wrong. The innermost log of 2 of x will be has to be positive for the next log 2. So everything above 1. So that we got it in the second condition. But since the log 2 of 1 is above the positive, I mean above the x-axis, I thought the domain was 1 comma infinity, not 2 comma infinity. How did it become 2 comma infinity intuitively? But the way you calculated it, I am able to understand.
Oh.
But graphically, how to think about this is like, if you want, you can take this at the end, maybe after.
So it's graphically, it's not easy to plot this graph. So you need some online plotters for that. That's why we didn't do this question the graphical way.
Okay, I'll do this in Desmos and keep.
Oh.
Yeah, I'll do this in Desmos and keep it ready. Maybe at the end you can answer this.
You'll be able to see it yourself. I mean, if
Yeah,
you see the
I'll
graph,
check it in
it
Desmos.
will be visible. Oh.
Yeah, I'll check in Desmos.
We're doing 6.3 now. Any questions from 6.3?
Yes, I'm 1 and 2.
The first question is, if the domain of fx is minus 3, 1, and the domain of f natural log of x is what they're asking. Domain of x. The natural log of x, if we look at this, is greater. It's actually, it takes all values, right? The natural log of x takes all values. To find the domain of, we have to find, we've done a similar question in the last class, I guess, for week 5, where I said that to find the domain of this, first you need x such that natural log of x is defined. That means you'd want this thing. And then you take the intersection with x such that, when we did the FOG one, no? So x such that your FOG is defined. No, it's such that this thing is in the range of x. Natural log of x belongs to domain of x. That's what you want. The natural log of x is greater than 0. And define, and then
Ma'am, can you explain this one once again?
We'll discuss this in very detail in the last class. We discussed why the domain of the composition turns out to be this. You can just check that that lecture. We've used that same thing here. It's basically when you find the domain of FOG, I'm repeating it again here, just quickly going through it. When you need to find the domain of FOG, what you do is first you take X and you want for this to be domain means what can you substitute here such that this function remains defined at that point. So you'd want X such that Gx is defined, right? So you'd want X in the domain of, let's just simplify this thing. It's X such that G, X in the domain of G. So you simply take the domain of G here. Just simplify it further. It's simply the domain of G intersected with X such that, and now next you want this thing. So you want Gx to be in the domain of F. So X such that Gx is in the domain of F. That's what we've done. That's all. Is that okay?
X such that when you write X such that ln X greater than 0, instead of that, shouldn't it be X such that domain of ln?
Yes.
X element of domain of ln, no?
It's just simply the domain of natural log of X, I guess.
Correct. Yeah, X element of domain of ln.
Ma'am, are we saying here that domain of FOG is subset of domain of G? Is that what we are discussing here?
Sorry, what?
Ma'am, I'm not getting what you're saying, but yes, I'm aware that a domain of composite function is the domain of the G function here.
So it's not the domain of FOG's domain is not the same as the domain of. It's this, the intersection of these two sets.
This is in week 5 actually. Week 5 composition of functions.
It's been discussed in the Solve with Us session too. You can watch that one. Okay. This is it. The domain of natural log of X is 0 to infinity. And then the domain of F is given to be -3 to 1. So this set we're discussing in detail. X such that natural log of X is in -3 to 1. That means the natural log of X has to be less than 1, and this is what it means. And this means, now since we can just take e to the power -3 here, when we take it's the same logic here. E to the power X is an increasing function. That's why we apply E in this inequality. And we get this. We would get X such that X is in between these two numbers. And if you take the intersection, we know that this set is already contained in 0 to infinity set. So it's just simply e to the power -3 and e to the power 1. Because the set is contained in this set, and the intersection of these two sets is this. Should be one of the options. Is it fine with everyone? Shall we move on to the next doubt?
Yes, it's clear.
Any other doubts from this activity?
Yeah, the second one. Second and the last.
There are only 4 questions. Are you guys not trying the questions or what?
No, I tried from my side. But
no, ma'am, we tried, but question itself is looking so difficult.
Maybe you should just revise the theory once again. That will help.
No, theory was just inverse of E of x is log x and then the properties. Nothing else in theory. It's all application, no? Like all these questions are like how to apply. That's where, yeah,
Basically, that's what you need to know about when
correct.
you are doing the questions.
That's
So
exactly where
that's
we
enough.
miss.
I think you should have been able to do these questions. But let's just do it here.
Ma'am, actually, I can't find the right approach to solve the question. We know the properties,
Okay.
we know the laws, but we don't find any approach that how to proceed, how to start the question.
Okay. So are you able to catch that up from here? Like, do you understand anything from here? Did this all help?
Yeah, definitely. Whatever you taught till now, yeah, we're able to understand the, yeah.
But this other person said that they're not able to find the right approach to do questions. So should I go into the detail of the approach that I've been following so far, or are you able to catch up with it?
Ma'am, question 1, if you could, repeat little bit again, that will be helpful, but I don't know if time is permitting or not.
Okay, so I think you had a doubt in this itself, right? This
Yes,
thing.
ma'am, we have to find out domain of f ln x, and after that what we are doing is what confusing me.
See, this is your composition function, right? So when you try to find the domain of this thing, you would want, basically the domain of a function is the values of x that you can substitute, that they can put here, so that your function turns out to be defined. That's the
Yes,
domain of
ma'am.
a function, right? So first you will check, this is the first function, right, that you apply to x. G is the first function that you apply to x. So you would want x such that x is in the domain of G. That's why we've taken domain of G, right? And then you would want gx to be in the domain of f, because next you'll apply f, right?
Yes, ma'am.
So now this becomes the argument. This becomes your x.
Yes, ma'am.
Is that okay?
Yes, ma'am, this much I'm able to grasp.
What are you not able to get then? This is the same thing written here.
Ma'am, then suddenly somewhere E has started coming after.
E, okay. This E, right?
Yes, ma'am.
This is E. I've written the reason here. E is an increasing function. So when you take something like x less than y, say, you can say that e to the power x is less than e to the power y, because it's an increasing function. No, your e is an increasing function. That's why.
Okay,
We
if
just
it is an
applied
increasing.
e here. Yes.
Yeah. Okay.
If it's an
Ma'am, so
increasing function,
how did you like intuitively know that okay, now I should use E as a base and then put it as a power?
it's natural log here. No, natural log means log base e. What else will you raise this to the power?
Okay, ma'am. Yes, makes sense.
What else can you do? Okay.
Yes, ma'am, it makes sense now. Yes.
Okay. Anything else, any other step till now that you people were not able to understand why it's done? Everything else I hope is clear. Okay. We'll start with this one then. The two, yeah, there have been some options given and we have to verify if these options are correct. So first option is if f is 1, 1 or not. So to check if this is 1, 1 or not, your natural log is obviously 1, 1, right? Natural log, the function, this function is 1, 1. And you have to see if this function, let's just say there is an x such that this thing, let's just say there are two x's, x1 and x2, such that this function gives the same value for x1 and x2. Then this function is not going to be 1, 1. Right? So we just need to make sure that this function is 1, 1. this one, because natural log is already 1, 1. Right?
Mr.
So,
Function inverse.
Oh,
sorry.
I didn't get that. Ln is 1, 1, correct? What is the other thing you're saying?
Okay, when you have this function fog of x, and you say that your f is 1, 1, right? What's
Correct, f is odd 1 because f is ln, correct.
yes? So if you have these two things here, let's just say your gx is not 1, 1. Then you will have x and y such that gx and gy are same, right? They give the same value. And your f is 1, 1. So this is going to be same. That means your fog is not 1, 1. So it depends on g if this function is 1, 1 or not.
Got
So
it.
it should be, so g of x should be in domain, right?
But yeah,
Yes, it should.
g of x is like entire, no? E power x minus e power minus x. The entire thing is g of x, correct?
Yes, this entire thing is g of x.
Correct. Got it. Yeah, proceed.
So we need to check this thing, right? One thing, there are like a lot of approaches to check if your function is 1, 1 or not. But when you've been given the sum of two functions, it's usually not very easy to plot. And so we don't go by the approach of graph or sketching the graph here. We're not using the graph thing to see if it is 1, 1 or not. We'll use the derivative approach. And we'll just see what the derivative of this is. So you'll have e to the power x plus e to the power minus x. That's the derivative of this function. And this is greater than 0. Strictly greater than 0.
Ma'am, but we are not taught a derivative till now, and I don't have much information about derivatives right now. So is there any other way that we can do this?
Okay. See, this is your function, right? Some other way would be
Can you also do by graph, right?
but it's not very easy to plot the graph of this, at least not manually. This is the function, and okay, we can do this thing here. And then we just need to see if there are two x, if there's x and y such that both give the same. So we have to check if some other approach works. The graph approach doesn't work here. It's not very easy. And the derivative one would work, but you say you've not been taught derivatives. So, and then
Derivative, in the
it's the
derivative,
definition left. Then.
can you,
Yes.
I have a doubt on the derivative part. So derivative, understand e power x plus e power x minus e power minus x is e power x plus e power minus x. But it has to be, if it is greater than 0, it is 1 to 1, is it? That's what you meant to say?
Yes, it's greater than 0, then it's going to be a strictly increasing function because the derivative never, see, it's a continuous function, right? So what happens in a continuous function is, if it's let's just say that this derivative is greater than 0, that means the function is increasing. So for it to decrease, you can only have.
Okay, only when it is equal to 0.
Aware of,
Okay,
yes, you're
yeah,
aware
yeah.
of the
Slope has to be
horizontal
equal to
line
0.
test, no?
Got it.
So
Okay,
for it
okay,
to
okay.
repeat values, it will have to
Derivative should
somewhere
be
have
0.
derivative 0, which is
Zero.
not
Okay,
possible.
okay, okay. Got it, got it, got it.
That's why you'll just have this strictly greater than 0 and it will be a strictly increasing function.
Yeah, I don't think people will understand this until they touch week 7.
So this is one way to do it. And then we'll have to look for some other way as well, which doesn't involve derivatives.
I just plotted this in Desmos. So e power x and e power minus x is almost cancelling each other. Means I was able to get a function like x cube around. Yeah, it's difficult only to understand unless you know how to plot this.
I don't think it will be easy to plot this graph on your own manually.
True.
Okay, just try something else. And can we take up this at the end of the session? Because we're not left with a lot of time.
Yes, ma'am, no problem.
Okay, just remind me at the end of the session. So we are moving to the 6.4 activity questions then. Any doubts from activity 6.4?
Oh, 6.3, can you just give a hint for the fourth at least?
Fourth.
I'm able to get 4 power x minus 2 power x minus 12 is equal to e. After that, I don't know what it is. I mean, equal to 0, sorry. Ln 1, 0.
Natural log on both sides. You'll get
Yeah.
4 to the power x minus 2 to the power x minus 12
Minus 12 equal to 0. Ln 1 is 0, no?
Natural log e1, right? Sorry.
No, you. It's a ln 1, no?
It's 1 here, no?
Ln 1 is 0, right?
No, it's not 0.
It's not 0.
Yeah,
Okay.
it's 0. It's 0. It's log base e, right? That's
That
e to
is
the power
0.
0, 1. Right. That's
So
0.
this is 0. But after that, how to proceed is what I'm stuck. Okay, convert it into quadratic and solve it. Got it, got it, got it. Convert it to quadratic. Got it, got it. That's where I was stuck.
Okay, we're moving on to the next activity, 6.4. Any doubts from 6.4?
Ma'am, I have doubt from 6.5.
Okay, let's just wait for if someone has a doubt in 6.4.
Yes, ma'am. 2 and 3.
Yes. We've almost discussed all questions till now. It's 2 and 3, right?
Yes, ma'am.
Log base 12, x minus 2. What do you have? I mean, you shouldn't be having a doubt in this one at least. It's just basic log properties. And then just go through the log properties. It's extremely simple. And I want you to try it on your own because I think you would be able to do it. Is that okay?
Actually, ma'am, I getting idea of how to solve these questions from you. That's why I asking.
Okay, this one is just the property thing only. You just have to apply the property of logarithm. So when you have this thing, when you have natural log and then something and then here, what you do is you take the inverse on both sides. So you get e to the power 1 and x. Similarly, what you do here is you just take you just raise both of these to the power 12. That's what you do. Here you raise it to the power e, and here you raise it to the power 12. This will give you x square minus 4 when you raise it to the power 12 and a 12. Or you can just understand this as log. This is, you must be familiar with this. If you have something like this just means a to the power b is x. That's what this thing means. And you can use whatever you remember better. And then you have x square equals 16 and x equals plus minus 4. But you can't put minus 4 here because then you'll have a negative argument for log function. Log functions cannot have a negative value. They don't have a negative value in the domain. So it's just x equals to 4 here. That's all. Minus 4 is discarded. Don't take minus 4 because the function is not defined for it. And by the way, when you write this thing, you should, like, even when you're using the property here, you should be aware of this. You should just keep this in mind that your x has to be greater than minus 2. And x here has to be, where x plus 2 has to be greater than 0. So you need x to be greater than minus 2 and x to be greater than, you want this thing. Okay. So to apply the properties as well, you need these two things. Because that's where this is defined. Minus 4 is not even in the domain of this function. You can't consider minus 4 here. And then question 3. It's natural log of x square by 4 minus natural log of x minus 1. This is log 5, 5. This is basically 1. And these two things you can club together. X square by 4, x minus 1 equals 1. And then this just turns exactly the same as this one. This is base.
Oh,
We
it's
have a natural
ln,
log
so that'll
here.
be E. Yeah.
The natural log. Just in this case, you just raise it to the power e. Raise this to the power e, raise this to the power e. That's all. Can we move on to the next activity?
So here
This
when I
is called the
solve it,
same way as the previous one.
when I
Yes.
solve it, I get an equation x square minus 4ex plus 4e equal to 0. But how to solve after that, I don't know. Answer is 2.
Okay, what equation are you getting?
X square minus 4ex plus 4e equal to 0.
X square minus
4ex x. No power, just next. Plus 4e equal to 0. This is what I'm getting. I think I hope everybody's getting this.
Okay, so when you have this thing, this is, it's just the, are you not familiar with the quadratic formula? Just use that.
Minus b plus or minus.
Yeah, my plus minus b plus minus
Plus or minus root of.
square root
Okay.
of. Just use this thing.
Okay. Okay. We'll check. Yeah.
Okay. We're moving on to the activity 6.5. Any doubts from there?
Yes, ma'am, both questions.
It's 15 to the power 7 square, right? And you need to find the number of digits. Let's just have a look at this thing first. Log base 10 and let's just say you have 100 here. Okay. And you get this as 2 because 10 to the power 2 is 100, right? And when you look at the number of digits here, in the argument, it's 3. So basically, when you need to find the number of digits in any number, this number is a huge number. You might not even be able to, it will have a lot of digits. Even if you use a calculator, you won't be able to just see all the digits in the calculator. So what we do is we use log base 10. Log base 10 helps you find the number of digits in any number. So if this is the number, you have 2 here, but you just add a 1 to it. So if you have x, say, and you need to find how many digits does x have, then what you can do is you can just add 1 to it. This is the number of digits x. Is that all right? That's what we use here.
Ma'am, so like we have to add 1 in 15 or in 49?
First, you just have a look here. We'll come to this one later. You have to add a 1 here. So the simple thing is, if you need to find the number of digits in x is a number, you need to find how many digits are there in x. You just do log base 10x and then add 1. That's the number of digits in x. Okay, that's fine with everyone. This is what you do to find the number of digits here. And then you have a calculator. Use that and you just see this, do one thing here.
It's 57.62 something.
57 point something, and then you have a 1 here. So you'll get 58.
No, it's
It's 58 only.
57.628. Should you round up or round down?
No, it's just take it 57. It's all right. 58. Is that okay?
Ma'am, so this 7 square won't contribute to increasing the digit?
It did contribute.
No,
What
it
is
did
the value
contribute.
of this
7
whole
square is
thing?
49, no? The whole thing.
Okay, we calculated everything. 49 into, 49 multiplied by log 15 base
Yes,
10. We calculated this using calculator and then we added 1 to it and we got 58, is it?
Yes. Ten to the power, it's something. If you do this thing, so x is coming out to be something, it will come out to be something between 1 and 2. It'll be very close to, because 10 to the power 2 is 100. So it will be something very close to 1. So this thing you're going to get 49 into 1 point, whatever this thing is. Okay.
So if I want to calculate the number of digits of 15 to the power of 7 power 2 in base 2, then I have to do log base 2, is it?
No, what your question was this thing. The log base 10 is used to find the number of digits in
No, that I understand. I'm asking if it is
Okay.
in the binary number. Like let's suppose 15 power 7 power 2 is in binary number, and there I want the number of digits in binary, then I have to do log base 2, correct? Here.
I'm not sure. I mean,
Since it's
then you'll
decimal, you
have to
did
have it
log
in the
base 2.
binary form, no?
Yeah. Then it
Then
should
you
be
have
log,
it in the 0-1 form.
correct. So here it is in decimal form, so we took base 10. So if it is in binary, we should do base 2.
I mean, I think so, yes.
That's how it should work, no? Okay.
Okay. And then the next one is easy. You should have been able to do this one. Suppose a certain amount of money M invested in a mutual fund at an annual rate of interest of 5%. What are you guys not aware of? Like, are you not aware of the formula of compound interest, or because it's just formula and then you have to substitute some values and calculate it? There's nothing to do. 1 plus the interest is 500 and it's compounded thrice in a year. So the compound interest formula is this. Or the compounding formula in general is this. M 1 plus R by 100N. N the formula where your N is the initial value. Your N is the number of times compounding is done in a year. And then your T is the number of years.
We can write this in the form of E, no? 1 plus E power. Oh, that is for continuous compounding. Okay.
Okay. Here. Then 3T. For a certain amount of money, M is invested in mutual fund at annual interest rate of 5%. How long does it take to triple the initial investment? So initial investment is this. When you want to triple it, this is what it is. This is your formula. This solve for T. The M gets cancelled here. You will get this thing. And you know how to solve this using logs on both sides. So is this okay?
Yes, ma'am.
I hope you'll be able to solve this part. Okay. So we're moving on to the next activity, 6.6. Any doubts from there? Any doubts from 6.6?
Can you do the second one?
This is it.
No, I have converted to the base power. Base, no? Okay. No, I got it. Sorry.
Okay. Want me to do it or you'd be able to do it?
No, I'll be able to do it. But convert that to the using base formula, right? Like you have to bring log 8 to the bottom. Okay.
Shall we move on to 6.7 then? Any doubts from there?
Ma'am, can we take my doubt now?
Yeah, let's just take your doubt then.
Ma'am,
your
I am sharing you the quiz link. It's from qualifier.
Okay. Can you just dictate the question? That would be better. Just put the question in the chat box. That's even better. Are you sharing the question?
Actually, all three in 6.7 is little difficult.
And
Could you
I
at least give
shared
us
the
an idea?
question.
Okay. First of the questions. Suppose you both starting the journey from the ferry ghat A, considered as the origin. So this is, can you just dictate it to me? That would be better. This is ferry ghat A. The origin. Just dictate the question to me. Whoever had a doubt in this.
And
One
I
towards
have doubt
ferry
in
guard,
this.
one go towards ferry guard B along the straight line y is equal to minus 2x.
Okay, just wait. Wait. Just hold on. Suppose two boats are starting their journey from the ferry ghat A, considered as the origin. One towards ferry ghat B along the straight line y is equals to minus 2x. So this is your line, y is equals to minus 2x. And the other towards the ferry ghat C along the straight line perpendicular to this one. Then you have a straight line perpendicular to y is equals to minus 2x. So the slope of this is minus 2. And the slope of the perpendicular one then will be the perpendicular ones have the product of this is minus 1, right? So it should be 1
And
by 2.
question has its own diagram.
Does it have a diagram?
So that's okay.
Yes, ma'am.
Whatever you're drawing is correct.
I don't think the question has a diagram. You'll have to do it on your own.
The question has a diagram, but whatever you're doing is correct only.
Okay. Along the straight line perpendicular to the path followed by B, the river is 1 kilometer wide. So your river is
Yeah, draw a line parallel to
perpendicular to the path.
x-axis, which is 1 kilometer
Okay,
away.
let me just give some time. Let me just have some time to read the question. Path followed by B along the straight line. This it's very hard B is somewhat here, right? We don't know where it is exactly. And the other towards the ferry path C along the straight line perpendicular to this one. We have a line perpendicular to this, which has ferry path C then, right? Is it
Yeah, he has shared the
okay?
diagram in the chat.
Let's share the diagram then. question really doesn't say which side is B on, but the diagram does tell us that it's here, and your C is on the line perpendicular. So we don't know how the line perpendicular is. This one, then it's here. Right. Then it says that the rivers, this is the river. That's 1 kilometer wide. Let's just have a clear diagram. This one's it. This is at the origin. This is passing through the origin. It's not that clear from here. And then you have this thing. And this thing here. And this is 1 kilometer. So it's the question then. The river is 1 kilometer wide uniformly. Suppose Rahul wants to go to the exact opposite point of A. This is A, and he wants to go here. Exact opposite point of A along the river. Now answer the given sub questions. Where are the sub questions? There are the sub questions too.
Ma'am, there are some questions in graded assignment which are not belongs to the uh, lectures or activity questions.
So the graded assignment is like supposed to check how much have you understood, right? So they are related to what's being taught in the lectures of that week. And you need to share the sub questions that this has, because you've only shared this picture and the question.
No, the point opposite to A will be 0, comma 1, correct?
What
Between B
is-
and C.
What's the question?
Question you're asking, okay.
Ma'am, question, yes, ma'am, I will upload the.
They're asking what is the distance the person has to travel if he's going to be, and that, no, you just mark that opposite point as D, no?
Yes.
Between B and C, there is one point, no intersection point. That point is D. Let's suppose it's D. They're asking what is AB plus BD and what is AC plus DC.
Okay, so from here to here and here to here.
Yeah.
Okay. So this line was y is equals to half x, right? This line was y equals to, what was it?
Minus 2x.
2x. Yes. And
But how do you,
this
how
is
do we
1.
conclude? But how do we conclude that the intercept is 0 here and y is equal to half x? It could be plus C, no? Like some intercept.
So this passes through. What would be what do you think is the intersection of these two?
Oh, okay. We have A 0, comma 0. Got it, got it.
It's 0 only.
Ma'am,
Then this
in question, it's given. In question, the chords of the B is given 0, 1.
That you can figure out from here as well. Like your y is 1 here, no? So if you put y is equals to 1, y is equals to 1 here, you'll get minus half. So x will be minus half. This one. You have been given that your y is 1 kilometers. So if you will put y is equals to 1 here, you'll get x is equals to minus half. So this is this point B. And then if you'll put y is equals to 1 here, you'll get x is equals to 2. So this is 2, comma 1. And then this is 0, 0. And this is the point. This point is 0, comma 1. Now I hope you will be able to find the distances. You know the formula of distance between 2 points, right? Just use that formula and find the distance from this and then add this distance. And then for the second one, take this distance and then add this distance. Is that okay?
Yes, ma'am.
What was your doubt here? Like if you had the whole diagram, it should have been clear. Any other doubt?
Can we do
No, ma'am.
activity 6.7, those 3 questions?
Yes, we are starting with activity 3. Sorry, 7, 6.7.
6.7, 1, 2, 3.
1, 2, 3. One thing is 1 by log 3 pi plus 1 by log base 4 pi. This is given to be m, and you need to find it. You need to check which one of these is correct, right? So if you will see the base 3 graph, you know that this is both of the bases are greater than 1, so both of them look like this. And not exactly this, but roughly they look like this, right? So, or this thing, if you look at this, let's just call this x. Let's just call this thing y. Only this denominator thing. So you'll have 3 to the power x equals to pi. And your pi is 3.1. We're just roughly estimating things. We're not calculating the exact value of x right now. So you'll have, though you can actually calculate the exact value of x from here, because you'll have the on-screen calculator with you. So you can calculate the value. But if in case we're not even allowed to use that, we can solve it then as well. So this is, so 3 to the power x is pi. So if you have 3 to the power 1, we're trying to find this a suitable value for x. It's 3. And if you take 3 square, it will be 9. Your 3.14 is in between these two, right? So your x is going to be, all in all, your x is going to be in between 2 and 1. And then you will have this thing. The same logic goes here. 4 to the power x. Let's just call it y. We call it y here. Y. So here you will get y to be 0 point something actually. So your y will be in between 0 and the same way. It's the same way we've done this part.
Yeah.
So it will be between 0 and 1. When you do 1 by x, it will be if you do 1 by x, you get greater than 1 by 2, right? This is what we get. And less than 1. Inequality just flips. And then here you will do 1 by y, you will get this to be greater than 1. This is what you will get. Have we done the right thing? 1 by x less than 1 and 1 by y
Hello, ma'am.
You're gonna join back? Live stream is still on. Meghna, were you able to solve activity 6.6, both the questions?
Let me go through it.
Okay.
Yeah, I could do it, but right now I cannot explain. But yeah, I tried, and when I matched the answer, it was matching. But I don't have an explanation right here.
Okay. First one I was able to solve. Second one was I'm finding a little difficult.
Yeah, I can now tell how to do the second one.
Do you? Yeah, tell me.
So I just took y, so left hand side is equal to y and right hand side is also equal to y. And then I took like a to the power y equal to x cube minus 1 and 2 to the power y equal to x minus, 2 to the power y equal to x minus 1. Did you get it?
8 to the power. I have to take the 8 on both sides.
I've just taken y equal to both of them.
Okay.
And then I've just removed the log function, so they will become a power, right? 1 by 1.
Okay. Okay.
So I've written 8 to the power y equal to x cube minus 1. And 2 to the power y equal to x minus 1.
Okay. Okay. Got that.
And then 8 to the power y we can convert to 2 to the power y to the power 3.
2 to the power 3y. Okay.
And then substituted the value from the second equation in the first equation.
Okay. Got it.
And
Thank
then you solve it. So
Yeah,
then
yeah.
we are getting x bracket x square plus 1. So only solution possible is x equal to 0, but 0 is not allowed here. Otherwise, the second log function will become negative.
What did you do after that? X minus 1, the whole cube is equal to x cube minus 1, correct?
So when you
That's
solve
it.
it, we will get x bracket x square plus 1 equal to 0. We'll get a quadratic equation. You solve it and we get x bracket x square plus 1 equal to 0.
Okay. Okay.
So that means if we take either x is equal to 0 or x square equal to minus 1. So x square equal to minus 1 is not leading to anywhere. So we'll leave that.
Okay.
And if we take x equal to 0, then with that x equal to 0, our this log function that is given here, that will become invalid. Because the values will become minus 1 in the bracket.
Got it. Okay. So no solution. Okay.
So no solution. Yeah. See, my approach is very basic. I do
No,
not know
I
much
get it.
complication, but that's how I did it.
Yeah.
I think
Makes
we can
sense.
leave the class. Nobody's coming back then. Thank you so
Yeah, I
much.
think. Yeah. Take care, guys. Bye-bye.